Great to be here. Thank you very much for giving me 5 minutes to talk about this super exciting talk. I'd like to start by acknowledging the traditional owners of the Great Barrier Reef region and also of where I live here in Wynnum, the Quandamooka people. I also want to say thank you to all the project partners who supported this project. Today, I'm just going to spend now 4.5 minutes talking about the actual data analysis for all those data junkies out there. But Tracy Schultz, Maxine Newman, who's talking after me, and Angela Dean will talk more about the project as a whole. Okay, what our challenge was is that we are all social scientists and we want to know what it is that makes people do certain behaviours in the Great Barrier Reef region that are either good or bad for the environment. So a key part of that is communication, and we want to understand how particularly norms about behaviour were shared across the reef region. But it's really difficult to know how we actually share norms. Many people work on it, and it's difficult both to see what norms are and what they how they're communicated. One reason is because it is communication text and there are millions and billions of words out there to analyse. Also difficult because norms are subjective. What you see as a norm, depending on your background, experience and expertise, is very different from what I might see as a norm. And the last reason is that this is qualitative analysis, looking at words to see how people are communicating. And qualitative analysis is inherently subjective. It's very difficult to do. But we still want to know what norms are being communicated. So what did we do? We decided to embrace the challenge with positivity and excitement. We decided we got about, I think it was 65,000 pages of text for various communication platforms across the reef, such as websites, social media sites, newsletters, etc. And we analysed that using AI, which we mean here as LLM, large language models. We look for two things: descriptive norms, what people actually do, and injunctive norms, what people should actually do. And then in those norms, those chunks of text about those norms, we categorised a bunch of different things which are there on the list. Who's performing that norm practice? What is the practice? Is it fertiliser use? Is it water efficiency practices? And are there other things such as what is hoped to be achieved by the norm and the geographic focus? I'm not going to look at those attributes now because Maxine's going to talk about them in a little bit after me. So we decided that humans are not capable of doing this amount of analysis for this amount of text. So we use a large language model. We went with Claude, which is very good at language analysis, as it should be, because it's a model based on predictive language analysis in itself. First thing we did is we fed all of these files, all of this text, into Claude and said, tell us where the norms are. You can see on the picture, there's the yellow highlighted bits and the green highlighted bits. Those are the bits that Claude said were either a descriptive or an injunctive norm. We then had a human look at all of those, many norm texts, and decide if they were or weren't a norm. We put it in a spreadsheet, and after that, we then asked again Claude through an API, which sounds more complicated than it is, but we asked it to look at every single chunk of text and say, is this a norm? Who is the communicator? And you'll see on the graph, on the picture there, a spreadsheet that we had for our output, which is Claude's decision about who was communicating the norm, which in the first example was Robert Leather, if you're there, hello. And then what the sentence was that Claude thought the norm communicator was being shown in, and why Claude thought that was a communicator. That's the most important thing. You always ask a large language model why they've made the decision they made. So we use this AI, large language model, just to help us because of the quantity of text. And there are a bunch of things that we did, our team. We obviously decided what we were looking for. We got all the text, we wrote the code, we did the API. What the AI did was actually help us analyse what those norms were saying. Now, the reason why it was so good, in my opinion, is that human coding, particularly of norms, is so subjective. From one day to another, we would all see different norms in different texts. And I guarantee if 5 of us sat in a table right now and looked at a piece of text in a newsletter, we would all see different norms as well. So the automated large language model provides a level of consistency and also transparency that humans can't do or provide, not without decades of time to do it ourselves. Now, I'm not going to talk about the results again because other people can talk about this, but we did find that there were many thousands of norms being communicated. Lots of them were particularly by the government, talk about that soon. Not many of them actually say anything about the reef. These are norms about behaviours that farmers should do, but not many of them specifically mention the reef, interestingly. And a lot of them were kind of biosecurity focused or very, very sector focused. Now, why am I talking about that? Aside from the fact that I know lots of you will absolutely love large language models and APIs and Python script, etc., etc. It actually is a really amazing way to start to better understand how people are talking about the reef. And when we know how they're talking about the reef, we can think about, are they talking about ways that will be beneficial for the long-term conservation for the reef or not? And if so, whichever way that is, how can we change this communication to generate better sustainable behaviours for the reef in that long term? What do you need to do? If you're not familiar with Python and APIs, it might sound awful and intimidating and horrible. It's actually not. And if any of you do want to learn it, I'm more than happy to be contacted. I love telling people how to do this and working together on projects. You do need to know how to open up Python. You need to know basically what an API is, and of course you need to know the AI, how they work. It actually can be time intensive, but once you've got it going, you can apply it to so many different projects. It's very exciting. Thank you very much. Again, just before I wrap up, Tracy is talking in the other pavilion right now, and she was fully across this entire project and would love to hear from you or anybody else who wants to talk about it in detail after this. Thank you very much.